Hi, Algebra 2. We are going to continue on our day 3, which is the very next page of notes if you're using the packet. Otherwise, for a lot of the notes today, we're going to start by looking back at our day 2 notes. So it would be good if you guys have those handy as well. We already talked in class a bit about what the z is. So remember on your formula packet, your z is equal to the x value minus your mean divided by your standard deviation. So remember this mu symbol is representing your mean. And then remember that this symbol looks like a circle with a little hook on the top. That's called little sigma, and that is representing your standard deviation. Okay, so we're given all that information usually in the problem, so we just have to know how to apply it to the formula. Standard deviation. I'm going to stop it there, abbreviate. So we started by talking about the normal curve. And your normal curve with z values is called your standard normal curve. You guys use z values to try to standardize everything that you're looking at. So when you're talking about your z-scores, if I'm going to label my z-scores, I'm going to call this the z-curve, which is also known as the standard normal curve. So I'm going to write that above it. Standard normal. So a little different than just the normal curve. This is called your standard normal, and it's because it standardizes your values. So remember how that z-score was the number of standard deviations you are away from the mean. So if I'm at the mean right in the middle, my z-score, so I'm talking about just z's, would be 0. And then if I go 1 standard deviation to the right or 1 standard deviation to the left, I am 1 standard deviation away or -1 standard deviations away. If I go 2, I'm now at +2 or -2. And remember, we only go out to 3 standard deviations. So we would go to +3 or -3. So let's take a look at our values from this rugby example that we were looking at in day 2. Let's go back for a second. Remember with our rugby example, the middle 68% was from 172 to 186. And that was because our mean was 179 and we had a standard deviation of 7. So let's go back and draw that. So we have 179 is in the middle. We have a standard deviation of 7. So since we have a standard deviation of 7, 1 standard deviation away is going to be at 186. Okay, and I'm going to draw my curve the best that I can. It won't always be perfect, but we'll try. Oh, all right. Not great. That looks better. So right here, this is at the mean, this is right in the middle, and 1 standard deviation away. Okay, so if I subtract 7, I'll be at 172, and then so on and so forth. I can go 3 to the right and 3 to the left. Okay. But remember, this is my middle right here, okay? What this question is asking me to look at is what percentage of rugby players are taller than 186 centimeters? Sketch a normal curve and shade the appropriate probability under your curve. If I'm going to shade that, I'm looking at 186, which is right here. And if it says taller, well, to get taller, I'm going to have to go to the right. So that means I'm going to be shading all of this area, everything that's under the curve to the right. Since we said that this shaded area is percentage or probability, if you think about it, what's the highest percentage you can have? And that's 100. So back up here when we were saying what should the total area be under the curve, it should be equal to 1, or if you want to think of it as 100%, right? So the area is actually 1, but it's a 100% chance if you fall somewhere under the curve. That would include every single possibility. Let's take a look at our second example. Find the z-score for 186 centimeters and mark your diagram appropriately. Again, 186 we can tell just from the picture. 186 is right here. So if my 179 is right in the middle, that would be a z-score of 0. And again, I'll try to draw the best that I can. So what would be the z-score for 186? If I'm just 1 standard deviation to the right of the mean, that would fall at a z-score of 1. So z would equal 1. Since it's positive, what does the z-score tell you? It means I'm to the right of the mean, right? And depending if we're looking to the right of that z-score or to the left, it says just find the z-score. So I'm not actually going to shade anything. I'm just looking right here. My z-score is 1. I'm to the right of the mean. All right, great. So pretty simple. If I know how to draw my curves, then I can figure out a lot of different probabilities. So let's take a look at a few more examples and figure out how our calculator or the chart that you guys looked at in your Algebra 2 formula packet can help you. So our example is, suppose that fuel efficiency in a Honda Civic varies from tank full to tank full according to a normal distribution. Most Honda Civics, they have an average of 34 miles per gallon when you fill up your tank, right? That's how fuel efficient your car is. And there's a standard deviation of about 3.5 miles per gallon. This is helpful to know since I have a Honda Civic, right? Popular car out there. So we want to make sure that we are getting the most efficient use of our gas because it costs money. So again, I'm going to look back over here and we're going to use both z-scores and not z-scores. We're going to see how we can do this with our calculator. So remember, if I'm using a z-score though, I have to find my z-score. So that's the one extra step. If I am using my calculator with z or my chart, I have to make sure I have a z-score to use. So it says, what proportion of tankfuls would get fewer than 30 miles per gallon? All right, so fewer than 30 miles per gallon. What I'm looking at here is the probability, P, that whatever amount of gallons you get is less than 30. That's what I'm really looking for. Okay, so that's going to be my ultimate decision here. If I use the calculator, where you'll want to be looking is under distribution right here. So since it's in blue, I'm going to have to push second and grab the distribution, and I'm looking for the normal curve. And we are going to be using number 2 where it says normal CDF. C stands for cumulative. We are not going to be using number 1 with the P. So we're looking at number 2 with the C. And then we have to tell our calculator some information. So let's figure out what information we are going to tell our calculator. Since this question asks for me to use the z-score, I'm going to have to find the z-score. So let's do a little side work. My z-score is going to be my x value, which is 30, minus my mean, which is 34. And then I'm going to divide by my standard deviation, which is 3.5. You should get a z-score of negative 1.14. All right, so we should get negative 1.14 as our z-score. So since this problem is asking us to use our z, what we are really looking at is the probability that z, not x, because we converted our x value of 30 to a z value of negative 1.14. So we're looking at z being less than negative 1.14. So the way that we put any of this into our calculator is by using the normal CDF, and I'm going to write over here on the side the order that we're going to put it in. So normal CDF is what we're going to grab on our calculator, and then it opens parentheses, and it asks you to put in the lower end of your interval, the upper end, the mean, and the standard deviation. And if it's easy for you to remember LUMO, L-U-M-O, that might be helpful to remember here. So LUMO, I'm going to go to normal CDF, and for us, our LUMO, all right, is going to be, it opens parentheses, I'm going to run out of space here, but that's okay. If if z is less than negative 1.14, if you're less than negative 1.14, how much less are you? So we're going to pick a very, very, very small number. So we're going to go all the way to negative 1,000. Comma, that's my lower end. Now my upper end goes all the way up to negative 1.14. Then, since we're in the z's, I have to tell it the mean and the standard deviation of the z distribution. Well, the z distribution always has a mean of 0 and a standard deviation of 1. Okay, so what probability do we get? Let's go back to our calculator. I'm going to put in the negative 1,000, comma, my z-score, negative 1.14, comma, the mean of z, which is 0, and the mean of standard deviation of z, which is 1. Okay, and I get 0.127, which is really about 12.7%. So what we're saying here is that about 12.7% of cars would get fewer than 30 miles per gallon. Because remember, 34 was the average. So about only 12%, about 13% actually closer, get less than 30 miles per gallon. That was using our z-score. We do not have to always find a z-score if you want to find a probability. We can just use the x value of 30. So another way that we can be putting this into our calculator is just using x is less than 30 and following the same pattern. I can say normal CDF, and my lower, my upper, and my standard deviation, oops, D, and then F, there we go. My lower, well, to be lower than 30 again, I'll choose a really big negative number, so like negative 1,000. I go all the way up to 30 in my interval. My mean, though, for the x value is 34. That's the original one from the problem. And then my standard deviation is 3.5. So there's a little difference when you use the z's. It's always 0 and 1 for mean and standard deviation. And then for x's, it's whatever your actual problem is giving you. Let's see if we use this in the calculator if it gives us the same answer. So we'll use, again, normal CDF. And we'll use the negative 1,000, comma, 30, because that's where we're going up to. Oop. And then our mean is 34. And our, goodness gracious, there we go. And our standard deviation is 3.5. And just make sure you close your parentheses. And we get the same thing. Off slightly, but that's okay. That's just from rounding. So 12.65, I'll round up to 12.7. So again, I get the same answer. So I have two options here for how I'm going to find my probability. Okay, about 12.7% or 0.127 for probability. So how will this change a bit when we look at what proportion of all tankfuls would get more, so there's a keyword, more than 40 miles per gallon. So now what I'm going to be looking for is, well, first I need to find my z-score for 40, because up here it was for 30, so that's going to be a different z value. And then I'll be looking for the probability that that z value is more than whatever my z-score winds up being. And the same thing down here, if I don't have my z, I'll be looking at the probability that my x value is more than 40. So think about how I'm going to put that into my calculator if I'm using the normal CDF. I can still use normal CDF, but since I always have to put in the lower and the upper, what would be my lower part of the interval if I want to go greater than 40, right? So if x is bigger than 40, the lower end is going to be the 40 this time. And how much higher can I go than 40? I can go up to infinity. So I'm going to be going up to, let's say, oops, I'm going to have to come down here. Let's say about 1,000. I'll use positive 1,000 this time. And then I have to use my mean, which is still 34, and my standard deviation, which is still 3.5. Okay, so that one is already set up and ready to go, and I can try that in my calculator. For this part one, though, if I use my z-score, I have to convert it to a z-score. So we're going to have to do some side work where we churn 40 minus the mean divided by standard deviation, and I have to get a z-score for 40. So go ahead and take a second to try that out and see what kind of probability you get. Again, if you don't have your calculator, you can also use your probability chart that we used in class. So in this example, only 0.044 probability of the cars getting more than 40 miles per gallon. So that is not very likely to happen. Go ahead and try C, D, and E on your own.